Hello everybody and welcome to our latest Marshall Hangout. We've had a bit of an intermission in these Hangouts, but I'm really pleased that we're able to have started again. The plan is to probably do one a month now and get more of our alumni to come and speak to us. So thank you very much, Eben, for actually offering to do one. I didn't have to chase somebody to get this one. It was great. Eben is a 2000 Marshall Scholar, so we know each other quite well from when I first started. And he is going to talk to us about his new book, which I'm very excited to hear all about. So thank you, Eben.
Thanks for having me, Mary, and it's great to see you all, even in these strange conditions of lockdown. And in many ways, the story I'm telling today is not anything new. Scientists have been talking about genetically modifying humans at least since the 1950s, when Watson and Crick first described the DNA double helix. So I happened to be kind of at the center of action when this actually, occurred. So I was invited to speak on an ethics panel in Hong Kong at a summit. Basically, the scientific leadership recognized that some new molecular biology tools had all kinds of new power and uses. And the particular tool at the center of my book is called CRISPR. So basically, CRISPR is able to produce targeted mutations in a way that is kind of a radical break from tools in the past. It's cheaper and faster than previous tools of genetic engineering. So I was in Hong Kong checking into the hotel as this story grabbed headlines. Two baby girls, Lulu and Nana, were reportedly born as healthy as any others. I learned about the experiment from another delegate at the summit in the elevator, and the guy at the center of the controversy, Dr. He Jiankui, was there sitting on the couch trying to explain himself to other scientists. The summit was chaotic. Reporters swarmed the event. I later learned that Dr. He had to move his hotel twice because journalists were trying to get an interview. And after he explained the technical details of the experiment, I spoke about the ethics of everything. Dr. He was detained by security forces. He was fired from his job, eventually sentenced to 3 years in prison. And after the summit, I traveled to mainland China to basically try to figure out what he had done. And I started out by tracking down some of the patients who signed up for the experiment. And these were parents who wanted to have a baby. And these were HIV positive men and women who were uninfected. And I learned in China, you can't avail yourself of normal reproductive technologies, even though they're widely available if you have a sexually transmitted disease like HIV. So these men who signed up for the study, in many ways, were trying to be ethical. They were trying to not transmit the virus to their wife. They were trying to not transmit it to their children, even though it's relatively low risk. If you take your medication, we now know, first of all, your life expectancy is very similar to normal if you're HIV positive. But it's also really unlikely that you're going to transmit it with unprotected sex. This is relatively new knowledge, and at the time of this experiment, that was just being, studied and publicized in the scientific community. The fact that if you're undetectable, if you can reduce your viral loads, it's untransmittable. But in talking to these parents, I really learned that this story was about social discrimination, about if you're HIV positive in China, you're likely to lose your job. You're likely to be, deemed undesirable on the marriage market. China has, interestingly, a really proactive support program for HIV positive patients. You can get free medication, which is not the case here in the US. The government will give you free tests, counseling, and lifelong medication, but still there's this pervasive discrimination in society. So the men and their wives signed up for this experiment, this radically new proposal to remake human nature, because they just had a very simple desire, many of them. They just wanted to have a healthy child. And they also wanted to have children that were unlike themselves in an important way. They wanted to protect them from the stigma that they had suffered as people with the virus. Quite ironically, these babies were subjected to all kinds of stigma. So, by comparison, any stigma that they might have experienced as a result of contracting this virus or health problems, I think was dwarfed by the sorts of inflammatory reports you saw in the media. So you saw them being called Frankenbabies. You saw journalists and even a bioethicist at the University of Oxford deeming this experiment monstrous. By implication, these children were not fully human. And in many ways, the scandal that emerged around this replicated some things that happened in the UK 40 years earlier. So many of you have probably heard about Louise Brown, the first baby born with IVF technologies. In those days, she was called the first test tube baby. And the same language was used around the birth of Louise Brown. People called her a Frankenbaby. And my friend and colleague at the University of Cambridge, Sarah Franklin, in sort of accounting for Louise Brown's life, she describes this lifelong struggle of a desire to be normal. Louise doesn't want to be seen as exceptional. And now, more or less, she's achieved that. She works as a mail shipping clerk. She does write books and occasionally goes on book tours and is sought out as an international expert on these sorts of things. But now that millions of IVF babies have been born worldwide, very much the story is not one of miraculous technology, but sort of a banal, new technique that is pervasive. Perhaps even some of you were conceived with IVF. So in getting into the details of this experiment, I learned that Dr. He violated a number of laws. One law was helping HIV positive men make use of IVF. That was one law that his lab violated. They also violated some clinical guidelines that prohibit doctors in China from transferring genetically modified embryos into a womb for the purposes of pregnancy. He didn't register this experiment initially with the National Clinical Trials Registry, and there was some other minor infractions. So he was sentenced to 3 years in jail. And this is a story that's somewhat remarkable in the histories of science. You don't see many scientists. Galileo was thrown in jail, but it's a pretty rare occurrence. Steptoe and Edwards, who were involved in the original IVF experiment, had a lot of allegations of scientific and medical misconduct levied at them. Their funding was cut off for many years. They were forced to stop their research, but eventually society recognized their valuable contribution. So while I was in China, I also tried to study the cultural context for this experiment. And I went to other facilities that were doing similar sorts of things. So this is a picture from China's National Gene Bank. And it's a facility that has ambitious goals. Their aim is to collect DNA from every single one of us, from every human being on the planet. And they're also developing a synthetic biology platform that aims to quickly move from reading DNA sequences, decoding, the genomes of humans and other animals and plants. But they also want to rewrite the code of life. They want to do this work of synthetic biology. And Dr. He's experiment can be seen as an experiment in this field of synthetic biology. And in the Q&A section, we can talk if you're interested about the details, the scientific details of Dr. He's experiment. But at this gene bank, not only did I find this picture of a woolly mammoth, the statue of a woolly mammoth, and grand claims about banking life with the idea that if things go extinct, we can reanimate them. But I found some exhibits that very much wanted to do the same thing as Dr. He. So I went to the gene bank in October 2017, the same year that that President Xi of China announced the China Dream. He was basically calling for this disruptive innovation that would displace and recenter, scientific innovation and take it away from Europe and the US and make China a country of innovators. So Dr. He's story is very much part of the China dream. You know, I visited his hometown. He grew up in a village without electricity, without telephones. He was born in 1984, and when his mother went into labor, she was having difficulties. The hospital was about an hour and a half away. They would have had to walk there and then take a public bus. And somebody who didn't have training in midwifery was summoned to the scene. And Dr. He, as a baby in 1984, came out with the umbilical cord wrapped around his neck. And she just cut the umbilical cord with a rusty pair of scissors. And, you know, that's all she needed to do. And he didn't have his first experience with modern medicine until he was in elementary school. He was lined up with all the rest of the children and given an injection. They were using the same syringe for all the children. So in part, what I've tried to do in this book is tell his story, tell the story of someone who had incredible ambition, someone who went from one of China's most impoverished regions to the city, Shenzhen, where there's an innovation economy, where they're very much trying to replicate the ethos of Silicon Valley, you know, the idea that you move fast and break things, that you ask for forgiveness rather than permission. So part of the book is situating that story in local cultural context. But I'm also exploring gene therapies more broadly. So in the United States, I spent time at Penn Medicine at the facility, a license to basically use CRISPR in the first gene editing experiment in the US. And eventually out of this clinical trial emerges an effective gene therapy for leukemia, something that could make chemotherapy obsolete. So with adults or, you know, children, the idea is that you can only modify some cells. You take the cells out of the body, you edit the genes and then put them back. And in this case, they were creating synthetic cells that are better at identifying and destroying cancer cells. But after this experiment was approved, the FDA put a price tag on it, or sorry, the company that drove the experiment, Novartis, put a price tag on it. And now they're charging upwards of $450,000 for a single dose of this gene therapy. A new Novartis gene therapy has a price tag of $2.1 million. So part of the book is really centered on these questions of science and justice. As these new disruptive medicines enter the clinic, who's going to get access? But also, you know, broader questions. You know, should we be modifying our DNA? Should we give parents the ability to choose the genetic makeup of their offspring? There's all sorts of ways that this experiment in particular of Dr. He and other experiments that are being imagined right now can be seen within this long legacy of eugenics. Eugenics literally means good genes, and you see eugenic projects at Nazi death camps, but also more subtle campaigns in the US where people were sterilized. The so-called feeble-minded were sterilized, gay people were sterilized, even immigrants were sterilized in an effort to improve the genetic stock. So as this technology enters the fertility clinic in particular, you know, who gets to decide what gene is a good gene and what gene is a bad gene? You know, what conditions are going to be seen as medical problems? And what kinds of biological diversity might we celebrate? You know, what do we want to hold on to in this moment when we have these tools that can remake the human species? So I think with that, I'll open it up for questions. There's a lot of things that I could ramble on about. So give me a prompt and I'll just keep talking.
So if you put your name into the chat, then Eben, you can call on them and they can unmute rather than typing out questions. I think it's just generally easier. So if you'd like to ask questions, just stick your name in the chat.
I can also just keep talking. Okay, Kira, go ahead.
Hi, I joined a little late, so I might have missed this, but I was really interested in what you were just mentioning about social justice when it comes to the gene therapy techniques. And I guess my question is, can you talk a little bit more about what you found with social justice? Are there are there groups that are working to combat it? And then also, or I guess like not combat it, but bring questions of social justice to bear on gene therapies? And then also, what does that have to say about the types of therapies that are being pursued? Because I would imagine that if it's only going to be available to very rich people, that's going to target diseases that are more common in richer populations. And so are you seeing a sort of population difference in the specific medical conditions that are being targeted?
Yeah, excellent question. So two protagonists in my book really speak to this question. So these veteran AIDS activists, Matt Sharp and Jay Johnson, are among the world's first edited people. 10 years before the experiment that Dr. Ha participated in, they signed up for another experiment, actually targeting the same gene. So maybe I'll get into some of the technical stuff and then come back to the social justice question. So both Dr. Ha's experiment and the experiment that they participated in were targeting a gene called CCR5. Basically, this is a receptor that lets HIV get into cells. And the idea is that if you delete or disrupt this receptor, the virus can't get in, and that you'll either be totally resistant or have some resistance. So Matt had participated in some of the early ACT UP protests. So, as all his friends and whole community is suffering and dying, this social movement staged these very theatrical and carnivalesque protests sometimes. So famously, May 1990, they stormed the NIH and basically called on the researchers to do more innovative, but also more risky research. So at the time, AIDS research was being focused on a single drug, AZT, and AZT had horrible side effects and wasn't very effective. So the mantra of the activists at that point was drugs into bodies. We want new experimental treatments that might well be toxic, might well not work, but they saw clinical trials as their only hope to stay alive. A big part of the ACT UP movement was also about science and justice, asking questions like who is getting AIDS, how and why, and how are things like race and class shaping not only, the epidemiology of this, who gets the disease, but also treatments, the homeless were very much elevated in some local ACT UP chapters. So this idea of equity guaranteeing access to the clinical trials, but then also the medicines once approved. Jay Johnson, the other protagonist who signed up for this study, has a similar story. Matt actually got some health benefits. His immune system was damaged by AIDS and his cell counts were abnormal until he got the gene therapy. And this gene therapy gave him enormous health benefits. He had a normal immune system for the first time since I think it was 1989 when he was first diagnosed with AIDS. Jay didn't get any health benefits. Jay's African American. He works for an organization called Action Wellness in Philadelphia. And his day job is basically working with the homeless, working with undocumented people who are being excluded from science and medicine because of their gender identity or race. And Jay signed up for the experiment because he was enamored with the purpose. He really wanted a cure for HIV, but he had a serious adverse event. So, to get this treatment done, you go in and you're hooked up to a machine that takes away your blood cells. So they siphoned off the white blood cells. It's a machine called apheresis. And they took billions of white blood cells and then tried to break the CCR5 receptor in each one of them. And then they shunted those back into the patient's body. So when Jay got the infusion going back into his body, basically he started having shakes and he got cold and experienced like full rigors. He just couldn't stop shaking. He'd previously worked as a nurse and had always been on the other end of these emergencies, and he saw them bring in the crash cart. So he knew that his life was possibly on the line. But even after that harrowing experience, and again, Jay didn't get any health benefits from participating in the study, he's emerged as an advocate for new research targeting HIV with gene therapies and other cutting-edge risky techniques. Jay insists, even if we get these therapies with astronomical price tags, we can still do the work of advocacy to get drugs into bodies as they come online. And I think your question also goes to research priorities, right? So the HIV advocacy community has done a really effective job. Initially, they had a politics of antagonism. They staged these protests, not only at the National Institutes of Health, but famously at one point they dumped ashes of, there was sort of a mass funeral that took place on the White House lawn, where they took the ashes of dead friends and dead lovers and dumped them on the White House lawn. But over the years, they went from those theatrical protests, these politics of antagonism, to collaborative politics. And so now you see alumni from the ACT UP movement very much collaborating with government regulators, collaborating with pharmaceutical companies to set the research agenda, before funds are allocated, and to help determine which lines of research should be pursued. You don't see a lot of other patient advocacy communities doing that work of science and justice. So in the book, I make a case in particular for cancer, and how cancer patients might learn from this legacy of HIV activists to prioritize those issues of science and justice as the experiments themselves are designed. So there's certain lines of research that are going to only result in these multi-million-dollar therapies. It's very labor intensive to take someone's blood cells out, to edit billions of cells and then put them back. But there's other lines of gene therapy research where the actual genetic change would happen in your body. In some ways, this is more risky. You'd be introducing an agent like CRISPR, or there could be a number of other delivery tools where the idea would be to try to infect some of your cells with either a new gene or selectively disrupt one of your genes. So those could be done much more cheaply. And I think getting the balance right is really important to explore these disruptive blue sky types of innovations, but also thinking about how to prioritize those issues of science and justice, not only after the drug enters the clinic, but from the design phase.
Thank you so much. It reminded me of a podcast I listened to about orphan drugs and the movement to sort of reclassify different drugs and the priorities there. I guess if no one else has a question, I have a follow-up question is, what is that relationship of cost to all of this? You mentioned it a little bit, but is it an issue with gene therapies that's being brought as like the right to a gene therapy, or is it still really fundamentally connected to price mechanisms and profit from the companies that are producing the drugs and the therapies?
So right now we're at kind of a critical juncture with this. So historically, the US has invested a lot in basic research and development, but now China is starting to pull ahead. So, we still lead the world with defense spending, but the NIH got, I believe it was 8.9 billion in their budget the last fiscal year. And China is investing a lot more in these basic scientific projects. So basically what we're seeing is that industry is stepping in. They're funding a lot of the basic research and development, and then arguing we need to charge these exorbitant prices to recoup some of this basic investment. But even if a lot of the funding for, say, this Novartis treatment for leukemia comes from private industry, there's still taxpayer dollars in the mix. And I think, that gives us, the right to demand a more equitable pricing structure. So after this therapy was announced, someone at Penn Medicine, where it was developed, made an argument saying, with this price, it would take Novartis just a couple of thousand treatments to recoup their investment. And it's really a price gouging at an unprecedented scale. And, can society even afford this? Much less, the insurance companies are balking. For the most part, insurance companies are refusing to pay. And even in the instances where they are paying, they're doing so in a conditional way, saying we're gonna pay, for this initial dose, but if it doesn't work, we want our money back. So we don't really know, the leukemia treatment has had a profound impact on people's lives who had no other options available to them. But we don't know, 10 years from now, 20 years from now, is there going to be a remission? Is there going to be some other unknown side effect? It's really still too early to say. So it looks like, oh, okay, so questions are starting to stack up now. So it looks like Lawson has the next one.
Go ahead, Lawson, we can't hear you.
Looks like you're still muted. Okay, we'll come back to you. So Chloe, if I'm saying your name right, I think you're next.
Yeah, hi. Thanks for sharing your work. I'm curious about these kind of like this middle ground between editing the germline and more on these kind of boutique IVF selection. So I guess screening embryos before selecting them, because that's not technically editing, but it still kind of has the intention of, or has maybe some of these eugenic undertones in selecting for screening for things like Down syndrome or BRCA variants. So I was wondering who gets to draw the line between selecting for a variant that doesn't have a BRCA mutation and selecting based on like a polygenic risk score for intelligence or certain other characteristics that we might deem more on the eugenic side of things. Is that genetic counselors? Is that kind of a wild west of private clinics? Who's doing that? Who's acting as a gatekeeper?
So that's an excellent question. And in the US, it's the Wild West. So one of the people I interviewed for the book is Helen O'Neill at University College London. And she explained how in the UK, there's a very clear government oversight. So there's I think it's called the Human Embryology Authority or something like this. So there's a database of conditions in the UK that the government, after wide consultations with everyone from the disabled community, to industry, to parents with genetic conditions, established this group. It's 400 different conditions, which I think is still quite large. And there's conditions in the UK database that concern me. So Klinefelter Syndrome, for example, not something that a lot of people talk about or know about. It produces a boy who is likely to be androgynous, tall, lanky, hairless, might have reproductive difficulties if this child goes on to want to have children of their own. But it's part of the human condition. It's part of human diversity. Around 1 in 500 children are born with this condition, and that's being targeted for systematic elimination. There's a long history of thinking about this. And in my field, Rainer Rapp wrote a great book called, actually I can't remember what the book is called. It came out when amniocentesis first entered the clinic. And she was looking at mothers who were being encouraged to do amniocentesis because they were deemed high risk, either because they were of what was termed advanced maternal age or some other thing. And mostly in those days, it was looking for Down syndrome. So Rainer Rapp describes what she calls moral pioneers, women who were confronted with new choices in the clinic, basically being asked to decide, do I want this child with Down syndrome or do I want to have an abortion? And from the clinician's point of view, there was often a lot of pressure from doctors or from genetic counselors to have an abortion, but many women decided to have differently abled children. So in the Wild West, here in the US, there are no clear regulations saying, what a company can or can't test for. And, you're getting some companies making completely irresponsible claims, whether it's in a prenatal context or in a context of, a young child or even an adult. So some the soccer test, you could give your child the soccer test and it would report back on a handful of genes that really explain a tiny fraction of athletic ability. There is no sprinting gene, there is no soccer gene. There were similar tests being offered on musical ability. And what I also found, not only in the US, but the UK, China, Australia, elsewhere, it's not just mothers who are being deemed so-called high risk that are being offered genetic tests these days. So a new suite of prenatal tests have entered the clinic, and it's something that you can get from your regular family doctor. All you need is a simple blood test. And in these blood tests, they're looking for fetal DNA. So they can diagnose a suite of things just from these simple blood tests. So now all pregnancies are being medicalized. So I think there is that, there's the tendency to look towards CRISPR and to see, eugenic possibilities on future horizons. But I think it's less easy for some people to see how these technologies are already in the clinic and operating. And, many of us in our lifetimes, if we decide to have children, might be confronting difficult choices. And, I think you asked about intelligence. There's one company in particular called Genomic Prediction that claims to be able to predict a child's intelligence. I would argue that this is junk science. The main scientist from that group, he's been working in Shenzhen, China. He's been on Radiolab talking about, he doesn't have concerns about eugenics, even though there's this guy named Adolf Hitler. I don't care. I'm, forging ahead with these experiments. But really the science just isn't there. Some things are really easy to predict. Blue eyes turns out to be very easy to predict. Skin color is a little more complicated, but you could choose based on, genomic markers to have a child with lighter or darker skin. So you really see, some of these eugenic questions in the clinic in quite a problematic way. And I really think there is an urgent need. There's the link to the Radiolab podcast where he's talking about, his eugenic project. So I really think in the US in particular, there's an urgent need to write new legislation. And it's so difficult, everything else in the news right now, to get any traction, but people are trying.
Who do you think should be responsible for kind of curating that list? Because as you mentioned, even though the UK has been doing that work, there are clear, I guess, things that don't seem purely ethical or correct. Like people with Down syndrome might argue that shouldn't be on that non-implantation list.
For sure, and I think disabled voices really need to be in the room. So there's a classic phrase from the disabled community: "Nothing about us without us." So someone named Sarah Katz has a great recent article in Discover magazine. Sarah is deaf, and she's arguing very forcefully, CRISPR should not be used to edit people like me out of existence. And there's other members of the disabled community that are making different arguments. So Tom Shakespeare in the UK, who has participated in a number of the Nuffield Council deliberations on this, he has achondroplasia. Basically, he's a little person. And he's arguing that people might want to, he's had two children that are like him, and he argues that people like him might want to have other kinds of children, children that are tall like us. I also engage with another disabled thinker, Gregor Wolbring, in the book, and Gregor was born as a result of a scientific mistake. His mother took thalidomide when she was pregnant, and he was among the thousands of babies who emerged with very different bodies. And Gregor insists that people like him are part of the new diversity of the human condition, that you can think about him as being anomalous or aberrant, but he insists, he likes who he is, that, his body's very different. He doesn't have, legs or arms like the rest of us do, but he's a biochemist and a very articulate and functioning member of society. So, as one of his questions, not only is CRISPR going to edit disabled people out of existence, it's also, can we live with the mistakes? Can we live with the mistakes of science? When science goes awry, can society learn how to live with people who are different from them?
Thank you.
Sure. Lawson, do you want to try again with your audio?
Yeah, does my microphone work now?
Yes, totally.
Okay, great. I have speaker problems. Anyway, thank you so much for sharing your expertise with us. My question really relates to Chloe's as well. And I guess I'm asking more in the sense of international regulation and the idea of, is CRISPR the new space race or the new nuclear race? How do you perceive, or how do you envision that policy on an international level is going to be regulated in regards to genomic editing? Will it be by international bodies of scientists? Will it be the UN? Will it be consortiums of countries? What are your thoughts on all of that?
So for starters, I think the case of Dr. He really shows what civil society can do in absence of well thought out and functioning regulations. So since then, you know, and for starters, the book chronicles all kinds of international adventures that Dr. He himself went on. So there's a clinic in Manhattan, the New Hope Fertility Clinic, run by Dr. Zhan Zhang, someone who got a Ph.D. from Cambridge, infamously or famously made the first 3-parent babies that a Marshall alum actually has written a lot about. Eileen Hunt-Bodding has written about Dr. Zhang's previous work. So Dr. Zhang and Dr. He went to Bangkok together after the birth of Lulu and Nana, and they were exploring setting up a clinic there. They also traveled to a zone of China that's being set up for medical tourism. So the Hainan province is a tropical island, a lot like Hawaii, but it's being set up to do innovative, risky experiments that would be illegal in other parts of China. So after the birth of these 2 genetically modified babies, before the data had really settled on whether or not they were healthy, they went to Hainan together and proposed to the governor a CRISPR clinic where they would bring you know, this tool to reproductive biologists, and it would be a training center where other doctors from around the world could learn to use it. So I think, you know, before civil society had a backlash and basically roundly condemned it, and you saw key members of the Chinese Communist Party pushing this particular venture from Dr. He's lab, and really seeing a chance for China to emerge as a leader in soft power by doing these kinds of biotech innovations. And there's a broad swath of other technologies that President Xi is supporting. And I think, you know, the scientific community rejected this, but also the Chinese public, just, you know, coming out on social media saying, how dare you treat children like guinea pigs? And, you know, at the end, as I said, Dr. He was thrown in jail. So there's other jurisdictions where this is completely legal. I think we're going to probably see countries like Thailand, where there's already a very robust IVF industry, places like Egypt. A clinic in Cyprus was advertising CRISPR IVF babies. Israel's likely to emerge as a leader in this field. And I think we're not going to see a unified international framework. There's a number of groups trying to work on that right now. We just saw a report come out from the US National Academies of Science, written in conjunction with counterparts in the UK. The World Health Organization is working on some kind of consensus statement. But really, if you look at any other issue, you know, whether it is related to, you know, genetically modified foods, where there was a big debate in the 90s, or something like global warming, what you see is a very patchy and uneven landscape. So I think at this point, you know, doctors and scientists who want to push ahead with this are not going to do so, because they saw what happened to Dr. He, not because there were clear laws on the books. The guidelines that he violated actually more pertain to licensing of fertility clinics. Rather, there weren't criminal penalties associated with transferring a genetically modified embryo into a woman for pregnancy in China. Now there's more robust regulations. He was ultimately charged with something akin to medical malpractice. But I think, yeah, any researcher in this space is just looking at the global map and seeing, you know, probably society's not going to let us do this yet, even though there is still that desire to, you know, achieve famous firsts. And also what I chronicle in the book, it's really a profit-driven enterprise. So some of the leading IVF companies right now based in Europe, based in the US, are recruiting CRISPR scientists. So it's happening. It's going to happen more. But I think, you know, this particular incident that I focus on in the book has really put the brakes on. I think, Sophia, you're next.
Yeah, thank you for the talk. It was great to hear about your work. I had a similar question to Lawson, sort of just in connection to the Uyghur population in China, though, because I know that there have been forced DNA collections to create a biobank of minority populations like the Muslim population there. So I'm wondering if you just could speak to some of the unique, along with these financial interests that you've been talking about, these totalitarian interests, and how the two are related in a way that makes it hard to address these ethical issues.
So I'm going to bring back this picture from China's National Gene Bank. So I already mentioned that they are trying to collect DNA from every single one of us. And the company that runs the gene bank, BGI, has also been labeled as a company that is involved in human rights abuses, in particular because of some of their subsidiaries being involved with forced DNA sampling of Uyghur communities. But BGI is not alone, and a US company, Thermo Fisher. So BGI is kind of the third biggest DNA sequencing company in the world. Illumina in San Diego is the first. Thermo Fisher, which I believe is out of Boston, is number 2, and BGI is number 3. So Thermo Fisher has also been doing this work to sequence the DNA of Uyghurs and help the Chinese government develop a forensic database. So I think we're in a moment where, you know, even before we're thinking about synthetic biology and the specific risks that come with rewriting DNA, where genetic testing is starting to become ubiquitous. There's a number of companies that I know that share BGI's dream of collecting a DNA sample from all of us. Ginkgo Bioworks in Boston is another one. And, you know, there's real trade-offs. You know, there's a lot to be said for having, you know, cutting edge science applied to the genome, you know, talking with your doctor, assuming your doctor is reasonably well informed about your propensity to certain kinds of diseases. Like genetics can be an important diagnostic tool. But, you know, we're also seeing in China, in the US, about how things can really go wrong and how we need better privacy protections built into this. So at the same time, this is happening to Uyghurs in remote parts of China. This is also happening in New York City. So the NYPD infamously has been doing a knock and spit campaign in some of the minority neighborhoods of New York, some parts of the Bronx and elsewhere, asking people in neighborhoods deemed to be high crime to offer a DNA sample. And when you're offering a DNA sample, whether it's to a company like 23andMe or Ancestry.com, that's potentially opening up yourself and your extended relatives to surveillance. So if crime scene forensic samples emerge, you could easily be implicated. And you know, so these are basically genetic fishing expeditions. In China, you see the targeting not only of Uyghurs, but also lawyers and human rights activists. In the US, it seems to be mostly targeting African American, Latino, minority population. So that risk is very real, and I think we need much more proactive policy and thinking in the space. Let's see, so I think Jamie, you're next, unless you have a follow-up, Sophia? Okay.
Thank you so much, Eben. This is really interesting and really important. So I'm an intellectual and cultural historian, so I try to think a lot about how ideas are events and how ideas become thinkable over time that maybe weren't before. And I think there's an interesting aspect of this with gene editing, because, I mean, you're talking about laws, regulations, the money, all of these really important things. But I'm wondering how you see, as a cultural anthropologist, this being adjudicated on the cultural level, on the social level, how you see these ideas trending, right? Are we trending towards a wider acceptance of gene editing? Or are we kind of, as there's still so many people who are horrified by this idea, that we don't see it anytime soon? And in particular, I was thinking about you know, I've been pregnant 4 times and I've had 3 babies. And my last one, I was like 3 days over. That made me advanced maternal age, you know, when my last one was due. And the amount of genetic testing and markers that was like proposed to me at that moment, it was a very different cultural experience of being pregnant. And there was a lot of disbelief. I refused a lot of it. You know, I for a number of reasons, but like even those uncomfortable encounters where people didn't think it should be a big deal that I might do a blood test for this or that, and I just didn't want it. So I was wondering too, how you've thought about the ways that in these kind of intimate medical spaces, even if you're not at a boutique IVF, just kind of run-of-the-mill pregnancy, right, that these ideas could start being shaped through those interactions.
Yeah, all super important questions. And one of the things, sort of going back to my disciplinary training as a cultural anthropologist, that I've really tried to do in this book is kind of deflate the importance of DNA. So first of all, I try to explain DNA to someone who might not have been paying attention in high school biology class, but really look at where these ideas about the power of DNA come from. So you know, the foundational moment of Watson and Crick describing the structure of the DNA double helix also comes with an unethical moment in science where a woman, Rosalind Franklin, you know, she'd been doing very careful X-ray crystallography of the DNA structure. Watson basically peeked at her results without her consent, and then did his own, you know, model with a sculpture. Rosalind basically passed away before the Nobel Prize was awarded, and she's often just remembered as a footnote in science. But I think if you go back to kind of Watson's biography and you look at, you know, some of his popular writing, you know, he was really at the forefront of pushing this idea that, you know, DNA is the code of life. It is kind of the book of life itself. There's all kinds of metaphors that he uses to emphasize how important it is. So, you know, in the 90s, when I was an undergraduate, the debate was all about nature versus nurture. You know, how much of this particular behavior or trait is the result of the social environment or, you know, interactions with other species, and how much is kind of innate genetics. And, you know, as genomics kind of came of age, initially what you saw was a big underwhelming result from the Human Genome Project 20 years ago. You know, Bill Clinton famously unveils the human genome, saying that we're 99.9% the same. But for years, decades, there weren't any concrete medical benefits that came from the Human Genome Project. And only now are we starting to see these applications enter the clinic. And I think in part it's just the history of investment in this idea and the investment in the field. So, you know, as gene editing is coming into the clinic, we're also finding all kinds of other things out about human biology, whether it's epigenetics, you know, the intergenerational signatures that our DNA can carry that, you know, affect how genes are expressed, to, you know, the microbiome, you know, the different organisms in your gut can really influence how you think even, and you know, what the phrase gut feelings really has a scientific basis now. So I've tried to kind of deflate the idea that DNA is the all powerful, you know, deflate the dogma about genetics. And then at the same time, really pay careful attention to ways that you can toggle certain genes and have profound effects. You know, there's a lot of hype about designer babies, and you know, there's a clinic, the same clinic that I already mentioned, New Hope Fertility Clinic in Manhattan, that has a page about designer babies on their website. You know, Sean Zhang, who's involved in these kinds of experiments, is basically saying inquire within if you want a designer baby. So I've already mentioned how racial phenotypes could be manipulated, but there's also, you know, talk about enhancing athletic performance. So there's a gene called myostatin that you could easily knock out with CRISPR that would produce a child with big bulging muscles, but a child that would also likely have heart problems. You could knock out EPO and make an athlete that would have enhanced endurance, but also be more likely to have strokes. You could knock out a gene associated with pain, and you could produce a soldier for the battlefield that would be incapable of experiencing pain. But, you know, infants that are born without this gene often bite off their own tongue or have serious injuries early in life because they don't feel these painful stimuli. So I think, you know, in terms of acceptance, there is a lot of horror. And I've tried to sort of tell a horror story, a horror and suspense story, but also really get inside of the promise of, you know, so if you're a parent and your child has leukemia, you know, you don't care if it's a gene therapy or if it's, you know, some kind of other, you know, scientific cutting edge experiment. You just want to hold on to that promise of hope for your child. If you're an HIV positive activist, you really don't care. You know, a lot of the folks that I talk to, you know, in some ways they understand themselves as already being genetically modified. HIV has reverse transcriptase, so elements of the HIV virus are already part of their genomes. So, you know, whatever kind of works. So, yeah, I think in the fertility clinic, there are parents who do want to have the perfect child. That's kind of the way that people talk about it. But what is perfection? And what is beauty? You know, the ideas of beauty inherit legacies of racism, legacies of colonialism. And one of the things that I found in doing the on-the-ground work in China is that the hospital that gave Dr. He ethics permission for this experiment runs a plastic surgery clinic where they're doing skin lightening treatments and Asian eyelid removal surgeries. So if we trust the private market to deliver us this technology into the clinic, I think it's going to go seriously wrong. So I really am trying to make an argument for more considered thought and deliberation and proactive engagement from, you know, communities of color, from the disabled community, not just from, you know, big pharma where there is a big profit to be made.
Oh, thanks. It's really interesting.
Sure. And let's see, I'm losing track of where we are. Okay, so Lawson. Oh, I think actually maybe we've already done all the questions. Is that right?
Yeah,
Are you keeping track?
I am keeping track. I think that's all the questions we have. And I think we're rapidly approaching the hour, so we will tie this up. But thank you so much. That was really interesting. I've learned a lot, both terrifying and hopeful, or in equal measures, I think, in some ways. And also around the kind of ethical questions around this stuff and the cost questions. I think it's been really fascinating. So thank you so much.
Thanks, Mary, for hosting.
Everybody's enjoyed it. We will be putting this up on our website, so please recommend it to everybody else as well. And I'll do a plug for you. Buy the book.
Yeah, and I should say the UK version is coming out in March, so it's available in the States, in Australia, and I think you can get it from booksellers in the States, and you can get it on Kindle. And there's actually an audiobook, and it's like the voice actor is much more articulate than me. So my worry is that I'm not going to get invited to do talks anymore, but everyone's going to invite the voice actor. But it is on Audible, and I think that's in the UK too.
Well, thank you so much, Evan, and I look forward to reading the book.